Some of you may have read of or heard of Muhammad al-Khwarizmi, who is credited with discovering some of our algebra concepts. He wrote a book, kind of one of the original algebra books, and this is actually a picture of one of the pages from it. In his book, he describes one of the concepts that we're about to learn about called completing the square. He didn't call it completing the square, but he actually used a visual representation to show a square and how you are essentially completing it. So I want you to consider the equation, this quadratic equation, y equals x squared plus 8x plus 5. Now remember, we talked before about how there are multiple terms or pieces. There's our quadratic piece, our linear piece, and the constant piece here. Now each of these pieces has a different area to it. Now this is going to be hard to make a square out of, but we're going to make a square out of these other two chunks. So x squared is literally a square with side lengths x by x, right? Because then x times x makes an area of x squared. 8x squared, well, I could have a length of x and a length of 8, but I want to spread them out all the way around this. So I'm going to need 4 of them. So I will have to have one here. Then I'm going to clone it. I'm going to go one here. Clone it again. One here. Clone it again for one here. So 2x, 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 there are 4 of them. So in this orange space there is a total of 8x. So the green space was my x squared, the orange space is 2x. 4 of them making 8x. So again, if this side length is x, this side length is x, all of the lengths of the orange ones is also x. So this height for it has to be 2. If this is x and this is 2x for the total area, this has to be 2 and this has to be 2. Meaning, if I want to make sure that I have, I'm going to go like this and show an entire square, one full square here, notice I'm missing those corner pieces. So I need to fill in those corner pieces with little chunks like this. Now how did I know this is 4? Well, because if this is 2 and this is 2, 2 times 2 is 4. So same thing, I'm going to fill in these chunks right here. I didn't align mine perfectly, but you can see it makes a larger square. Okay, this is the visual. Now I'm going to explain what it means, how it looks. So we're going to consider our equation. Now because I'm mainly concerned with the x squared and the 8x, I'm going to get rid of this 5 from both sides. So I'm just going to move it over to the other side. So y minus 5 equals my x squared and my 8x. Now I split it into 4 pieces, so 4 2x's. Remember, 4 2x's still means 8x, and we can actually see here are my 4 2x's. Now, to complete this large square, I needed to add on 4, 4, 4, and 4. So really, I added on 16 to both sides. So I can see I'm just looking at an area. I subtracted the 5, and I added this 16 to both of them. Now we're going to simplify here. This side over here was the area of my square. Notice this side length and this side length, I guess we can call it width and height, they should be the same. This should have a length of 2, this should have a length of x, this should have a length of 2. So 2 plus x plus 2. That's my length here. Now when I look at the height of my square, 2, x, and 2. So 2 plus x plus 2. This was all of my square. This was all of the area. Area, remember, is length times width. So we just called this the length times the width. Now instead of saying 2 plus x plus 2, we're just going to simplify that into x plus 4. X and these two makes an x plus 4. X and these two makes an x plus 4. I'm also simplifying this side where it said y minus 5 plus 16. I'm going to combine my minus 5 and my 16 into just y plus 9. Now at this point, notice x plus 4 times another x plus 4. A binomial times itself, that's the same as calling it that binomial squared. So x plus 4 is up here because x, 2, 2, and x plus 4 is along the side, x, 2, and 2. So x plus 4 squared makes the whole area of this square. Now we want to keep y alone, so I'm going to subtract that 9 back so that it says y equals x plus 4 squared minus 9. Now notice at this point we've taken it from a standard form into a totally different form, something that has this squared with it. Okay? Now what is so special about this chunk? Now I want to come back to our original version. Let's find the vertex. So we need to do negative b over 2a. So negative b over 2a would mean negative 8 over 2 times 1. 2 times 1 is 2. Negative 8 over 2 is negative 4. Notice that this negative 4 is the opposite of what is in here. This is a plus 4. This is a negative 4. When I plug in negative 4 back into my equation, negative 4 squared is 16. 8 times negative 4 is negative 32. 16 plus negative 32 is negative 16. Negative 16 plus 5 is negative 9. So here was kind of my steps for that. Notice negative 4 was the opposite of this piece. Negative 9 was right here. What this means is here and here are the vertex. The negative or the opposite of this one and what this one actually is. So I want to come back to my steps here, show you exactly what I did, because what we did here is called completing the square. These are the steps for completing the square, and I do want you to write these down. So when you complete the square, you don't have to draw the visual. The visual just helps us see that, oh, it is an actual square. We start by subtracting the constant. So this 5 at the end gets subtracted and moves over here, so it's now y minus 5 equals x squared plus, remember this is like saying 8x. Next we're going to add half of b squared. So remember b was 8, half of that is 4, 4 squared is 16. So we're adding 16 to both sides. So again, I want you to write it down or think of it as half of b, b over 2, gets squared. And that's what we added on. Now in this step, this really only makes sense when you see the picture, because we split it up this way. If you didn't see the picture, you can go directly from here to here, because what you're doing is you're turning this x side over here where it's x squared plus, remember this is like 8x plus 16, x squared plus 8x plus 16. We're turning that into x plus b over 2 times x plus b over 2. The reason this works is because if you were to FOIL this out, x times x is x squared. X times 4 is a 4x. 4 times x is another 4x. Those two 4x's would make 8x. And then 4 times 4 is the 16. So that's why this works out to be able to turn it into x plus b over 2 times x plus b over 2. Now again, also notice on this step, we simplified this side. Because we subtracted the constant and then added this piece, we're going to put those together into one. After you turn this side into the two binomials, now turn it into just one binomial squared. So instead of x plus 4 times x plus 4, it's x plus 4 squared. And the last thing, just bring this constant back over. Subtract the 9, and now we have y alone. Okay, so this is the end result. This is what you get after completing the square. You end up with this form of our equation. So we're going to try it again, but this time we're going to use numbers that don't come out as nicely. So again, my x squared is this chunk. 10x needs to get split up into 4 pieces. So that's kind of hard to think about because 10 doesn't split well into 4. So it's 10 over 4 here, 10 over 4 here, 10 over 4 here, and 10 over 4 here. Now notice I called them each something different. 10 over 4 is the same as 2 wholes and 2/4 left over. That's the same as 2.5 or 2.5. So we can consider each of these 2.5x or 2.5x or 10/4 x, whatever you want to call them. Basically all we did was take this and split it into 4 pieces. Now, to fill in these corners, we need to make sure we are putting in the right amount. So look down in this corner. If this length is 10/4 and this length is 10/4, the area of this little square would be 10/4 times 10/4, which is 116ths. 10 times 10 is 100, 4 times 4 is 16. So that would be the same in all of our corners. We need to add 4 of those into every piece. Now we've completed the square. Notice again, we didn't use this 12 at all. Since this 12 wasn't used, the 12 gets subtracted right away. Remember, that was our first step, subtract the constant. Delete that. We're adding 4 of these, so we're actually adding 400 over 16. 100 over 16, another 100 over 16, another. It's actually 400 over 16. So that can actually be simplified. Instead of calling it 400 over 16, we're just going to call that 25. Basically what we did was we added 25 in total. Now again, how can we make sure that that was 25? It's always half of b squared. Half of 10 is 5, squared is 25. So it's 25 that we added to both sides. So now, again, we can see at this step I was calling it, each of these were 10/4 and there were 4 of them, so 4 of the 10/4. But again, all it really means was this was our b value, that 10x is the same as this one. So we subtracted the 12 over right here. We added 25 because it's half of b squared. Now I'm going to take this chunk and split it into my length times my width. 2.5 times, or 2.5 plus x plus another 2.5. Same thing down this side, 2.5 plus x plus another 2.5. Instead of using the whole piece to be called my length, I'm going to simplify those. This piece would just be x plus 5. This piece would just be x plus 5. And on my left side, instead of minus 12 and plus 25, I'm just going to call it y plus 13. Now again, I've got 2 binomials, but they're the same binomial, so I can just call it x plus 5 squared. And lastly, I want to get rid of that 13, so x plus 5 squared, subtract 13. So again, here is my final result after completing the square. This standard form means the same as this form. And again, here and here are my vertex. It's the opposite of the one inside and the exact same of the one on the outside. So my vertex is at -5, -13. Again, let's just double check all of those using the steps as we go. I started with my equation. I subtracted the constant from both sides. I subtracted that 12. Now again, when I look at this step, I was adding these little squares everywhere. One here, one here, one here. Oops, doesn't want to go. One here, one here. There were 4 of them, so I added 400 over 16. but that's kind of hard to think about. So let's just think about I'm adding 25 to both sides. I took half of b, which is 5, and squared it. So 25 got added to both sides. Now, again, I'm looking at them all in my lengths, but that's kind of weird to think about. So instead of thinking of it, again, as the square, let's just turn this into x plus 5 times x plus 5. This chunk, if you FOIL this out, will be the same. X squared, 5x, 25, right here. Simplify this side and get y plus 13. So first step, second step, third step, fourth step is to change these two into one that is squared, and then subtract the 13. So, what is so mathemagical about that, about everything that we just did? This shows us what is called the vertex form. Now, I want you to write this down in your vocab area. Vertex form of quadratic functions is y equals a times this chunk x minus h squared plus k. If you have something in this form, h and k is your vertex, and a is that same reference a we were using before for the standard form. Now the ones we were using didn't have a reference a, and that's all right, but what we were able to find was the vertex from this vertex form. So please write this down. This one is very important. So that's kind of the end of video 3. We discussed completing the square and vertex form.